Okay, so what we're doing today is kind of weird, okay? What we're doing is we're taking a triangle and we're putting it on a coordinate plane and we're giving it coordinates, okay? But the coordinates aren't numbers, they're variables, right? And so, like I said, it's kind of different, it's kind of weird, but it's not really all that hard. I'm going to show you how to do a coordinate proof. I won't make you do one, but I want to show you how to do it, okay? But anyway, a coordinate proof uses figures in the coordinate plane in algebra to prove geometric concepts, okay? So, and it kind of makes sense once you see it. It's just kind of tedious. Now, when you place your triangle on the coordinate plane, there's a couple of rules that you need to follow, okay? It's a couple of guidelines that I've set for you. And the first one is you want to try to use the origin as the vertex or the center of your figure, okay? So, like, you have a triangle, you're going to place it on here, you want to use the origin as the center or as a vertex, okay? Place at least one side of the polygon on an axis, okay? So, like, if you're going to put a vertex here, then you're going to have a side that goes along either at the x or the y axis. Sometimes if it's a right triangle, it'll be both axes. Step 3, keep the figure in the first quadrant if possible. If you can keep it over here, everything's positive, it's going to be and then use coordinates that make computations as simple as possible. Now, you'll understand what I mean by that when I actually show you a coordinate proof, okay? Alright, now before I do this one, there's just a couple of things that I need to show you, okay? We talked yesterday about isosceles triangles, right? We said that they have two legs that are congruent to each other, okay? They also, by the isosceles triangle theorem, have the base angles that are equal, yes? If I draw a height on an isosceles triangle, even an equilateral triangle, so you draw the height, go straight down, and it's perpendicular to the base, correct? If I drop that down, I created two right angles, right? Well, I know that if I look at, we'll call this triangle ABC. If I look at this triangle ABD and triangle CBD, I can prove those two triangles were congruent, couldn't I? Okay? By angle, side, yes? So I'm going to write angle ABD is congruent to angle CBD by angle, side, right? So then I can say that these two parts are congruent, yes? By CPC. AB is congruent to CD by CPC. And then from that, because these two segments are equal to each other, what can I say about this point D? It's the midpoint, okay? So D is the midpoint of AC. Okay? And that would be by midpoint here. Now, you're not going to have to do this. You're not going to have to do a proof like this. But I'm doing this to show you a point. Is that when you draw the height on an isosceles or a right triangle, it always goes to midpoint. Okay? It always goes to the point in the middle. You're going to see why that's important here in just a second. Okay? Alright, now, let's look at this first problem. It says, position and label isosceles triangle JKL on a coordinate plane so that base JK is 8 units long. Now, when it says position and label, that means you want to put it on the coordinate plane and you want to come up with the ordered pairs. Okay? So, it's an isosceles triangle. Put it on, it says put it in the first quadrant if possible. Put a vertex at the origin. Put one of the sides along with the axis. Okay? And it tells me that my base is JK. So this is going to be L, and it's isosceles. It also tells me that the base is A units long. Now, all this has done is positioned it. Now it has to label it. Okay, that means I've got to come up with the ordered pairs. Okay, so J is at the origin, so that's easy, right? What's the ordered pair for J? What? 0, 0. Okay. Now this is A units long. So if I go over A units to K, what would that ordered pair look like? A0. Because the first number tells you which way to go left or right. The second number tells you which way to go up or down. Yes? So I've got from the origin, I have to go to the right A units, and I don't go anywhere up or down. Right? Okay, now here's the tricky part. When you find coordinates, the lines are always vertical and horizontal, right? That you use. So like you go over horizontally and then up vertically, right? So it's like if I were to drop this height, I would have to go over and then up to get to L, right? So how far would I have to go over before I had to go up? Half of A. So that would be A over 2, and then we go up a height that we don't know. And so when it's not any relationship to that number, we create a new variable, and we'll call it B. Okay? And this half, you could put actually, you could do it like this. You could do 0.5A, comma B. You could also do 1/2 A, comma B. Whatever you're more comfortable with. Okay? Alright, so everybody see what I did there? That's positioning and labeling. Okay, here's another one. Find the missing coordinate of isosceles right triangle EFG. Now, before you do this one, some of you may not remember all the terms of a right triangle, but in a right triangle, the two sides that make up the right angle, those are called legs. And then the side across from the right angle, what's it called? This is called the hypotenuse. Okay. Now, on this one, it says find the missing coordinate of isosceles right triangle, EFG. Now, notice it says isosceles right. Anytime you have a right triangle, you want to put that right angle at the origin. Okay? And then these are my legs. It says that they are isosceles. Okay? So I want to come up with these coordinates. Well, F is located at the origin, so that's easy. What's its coordinates going to be? 0, 0. Okay? Now, it says right here at E that it's located at blank, comma, A. What does that tell me? What does this blank, comma, A tell me? It's A units up. Okay? A units up. And so what's this coordinate going to be? It's going to be 0. And if this is isosceles, if this is A, then this is A as well. And so my coordinate for G would be what? A, 0. Questions on that? Alright, I'm going to do this one in 2 days because I want you to see how it can be done when you put it in the first quadrant or when you center it at the origin. Okay, so I'm going to do it in 2 ways. Alright, so it says position and label equilateral triangle XYZ with sides 2A units long. Okay? So, I'm going to put it in the first quadrant like I did the other one. And it says equal out, that all the sides are equal, and they're all 2A units long. Now the other two sides are 2A units long too, but that doesn't really matter because when you pick ordered pairs, you're going vertically and horizontally. Okay, so it's really important to know that this base is 2A. Alright, so it's triangle XYZ. X is at the origin, so it's what? 0, 0. Okay. This says it's 2A units long, so what would the coordinates of Y be? What is it? 2A, 0. You go over 2A units and you don't go up any. Alright, now, what about Z? I have to go over and then up. Now this is equilateral, but it's just like an isosceles triangle. If I go over, where do I go? A units, because it's half that base. So you go over A units, and then you go up a height that we don't know, right? So we can let it be B. Okay, now I'm going to redo it. You can just do yours over to the side if you want to. But I'm going to redo it so that I put it at the center at the origin. Okay? Alright, so this time I've got my isosceles triangle here. X, Y, Z. This is still 2A units long. Okay? Now, when I go to come up with my Y coordinate, how far am I going to go over? A units, it's half that base. So it would be A comma 0. And then to get to my x, what am I going to do? Negative x. I'm going to the left of the origin. So it would be negative A comma 0. Then to get to z, I don't go anywhere left or right, so my x is 0, and then my height, I really don't know what it is, so I'm just going to let it be. Okay. So that's what it would look like if you centered it at the origin. Okay. All right, now, this is a coordinate proof. Just write a coordinate proof to show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay? How do we know that two lines are parallel? Back from chapter 3. How do we know that two lines are parallel? Do what? They never cross into each other, yes. But in regard to coordinates, what ensured it happened? They had to have the same slope, right? So what we need to do is look at the slopes, okay, and determine if they have the same slope, okay? Now, we have triangle ABC, and I'm going to put it in the first quadrant, okay? Okay, so there's triangle ABC. It says S is the midpoint of AC. So there's S, and it's the midpoint of AC. And then here's T, it's the midpoint of CB. We want to show that this ST is parallel to the AB. And to do that, we're going to have to look at their slopes, okay? If their slopes are the same, then they're parallel. Now, in order to do that, I need coordinates, right? For each one of my vertices. A is at the origin, so I'm going to let it be 0, 0. Now, I'm going to pick some coordinates, and you think, why are you doing that? But you will see why in just a moment, okay? For B, I'm going to let this length here be 2a units long. So this right here is 2a comma 0. I'm going to let, from here to here, is going to be 2b, and then from here to here is going to be 2c. I don't know that this is isosceles, so this does not necessarily go to the midpoint. That's why I'm going to let it be 2b instead of a. Does that make sense? Because we don't know that this is isosceles or equilateral. So this is a distance, and this is a distance that I really don't know. Okay? So this I'm going to let be 2b, and this I'm going to let be 2c. Okay? So this length here is 2a, and then I go over 2b and up 2c. Okay? And you're like, why are you using the 2's? We'll see. Okay? Alright. Now, these are midpoints. S is a midpoint, and T is a midpoint. So how do we find the midpoint of the segment? Remember? Midpoint, what do? Add together and the average of the endpoints. When you average something, what do? Add and divide, right? Add together and divide by 2. So if I want to find the midpoint of AC, I'm going to add these coordinates together and divide by 2, right? Okay, so I want to find the midpoint of AC, and I want to find the midpoint of BC. Okay? Alright, so to find the midpoint of AC, I'm going to add the coordinates together and divide by 2. So do 2b plus 0 divided by 2, and 2c plus 0 divided by 2. Well, that ends up being 2b over 2 and 2c over 2, which ends up being bc. Everybody with me? You see now why I used 2a, 2b, and 2c? Because if I didn't, I'd have fractions, right? Okay? That goes back to use coordinates that make your computation as easy as possible. So here's my coordinates for S, BC. Now B is a little trickier because we've got two variables. That's okay. Alright, so here we're going to do the same thing. We're going to add our x's together. 2a plus 2b divided by 2. And here I'm going to have 0 plus 2c divided by 2. Okay? This is going to just be a plus b, and this is going to just be c. So these coordinates are a plus b strong. Okay, yes. How did I get that? I divided 2 into both of those, which give me a plus b. And then here, 0 plus 2c is 2c divided by 2 is c. I just skipped a step. Did I lose you when I skipped a step? I'm sorry. Okay, so everybody with me on how I got the midpoint? Okay, now I need to look at their slopes. Okay, I've got my coordinates. Now I need to look at the slope of ST and the slope of AB. Okay? Alright, so we're going to look at the slope of ST. And remember, slope is y minus y over x minus x, right? Okay? Okay, so we're going to do ST first. So I'm going to do C minus C over A plus B minus B. C minus C and then A plus B minus B. Everybody see how I did that, right? So if I simplify that, I get 0 over A, which is 0. Then I'm going to look at the slope of AB. Do the same thing, 0 minus 0 over 2a minus 0, that gives me 0 over 2a, which is 0. So what does that tell me about the slopes? They're the same, and if the slopes are the same, that means the lines are parallel, okay? So, the slopes of AB and ST are the same. Therefore, ST is parallel. Alright, now don't be having a heart attack. I'm not going to make you do it all by yourself. So I know it's overwhelming, okay? I just wanted you to follow it, alright? And now you can be thankful that you don't have to do it, right? Okay, if you go major the math, you'll have to do something, okay? But anyway, that is important. Alright, and that's really, it's not that hard once you kind of look over it a few times and try it, but it is a little daunting, I know. The main thing that we're going to do today is this. That's easy. Yes? That's easy. Okay, so you're going to label and position and label these lateral triangles, okay? Alright, any questions? Alright, our assignment is